But all of these things we need to know. Like anything raised to the 0 power equals 1, right? Except that a was 0. But other than that, anything raised to the 0 is the number 1, right? It's not that thing raised to the first power, it's the number 1. Okay. If I multiply a to the m times a to the m, the key point being that these are the same base, right? This a is the same thing. Then you can simplify by adding the exponents, right? M plus n. If I divide a to the m divided by a to the m, as long as the bases are the same, the a's are the same, it simplifies as a to the m minus n, right? If you raise a power to a power, right, the operation between those two is multiply. Right? It's like this, if I did a to the 3rd times a squared, that's a to the 5th, because that's where you add them. But if I did a to the 3rd raised to the 2nd power, that's a to the 6th. That's when you multiply them. Okay. If you have an exponent outside parentheses, then you can distribute it inside the parentheses as a to the n, b to the n. Or if it happens to be in a fraction inside the parentheses, it's still the same thing, right? A over b to the n is distributed. A to the n divided by b to the n. Okay, you always can just bring that power inside the parentheses. And then the last property is negative exponents. How do we get rid of a negative exponent? You flip it to the other side of the fraction, right? So if it's to the negative n in the numerator, it's to the positive n in the denominator. Or it could be the same thing. It could be like 1 over a to the negative n in the denominator becomes a to the n in the numerator, right? Whatever it is there, it's the opposite in the other side of the fraction.